we were asked to speak on today is operators as it applies to storage. And in terms of operators, we'd be talking about being in Kubernetes. And then day two maintenance. So sort of two different ideas, though very closely linked. We'll see that operators are really helping us do day two maintenance. And I'm going to take you through some slides. And then Sagy is going to actually do a few demos to show you how, in the face of application IOs, we can actually do these day two activities. So I can't see the slides. Okay. All right. Well, excuse me. All right. Well, I will have to look over here so I know what I'm talking about. But in terms of storage, we know that traditional storage is not portable, doesn't move, as I've heard multiple times today. I want my storage to move to where my workloads are, whether that be within an AZ or at least have high availability. I want them to be accessible, and in particular, I want to have day two operations, and who is actually managing the storage. So as at least we have found in our work, is that as you look at moving into a Kubernetes kind of platform, the question of who's managing it gets really interesting, because it's not, since storage now can be a workload, the idea of the traditional storage group managing it doesn't really make sense anymore. So the day two activities need to be essentially within the Kubernetes framework, so that when you do things like upgrade or add storage or things like that, you're actually using Kubernetes to do that. So what is Rook? So what we decided to do is to use an example of a storage operator that actually has quite a, I guess, a long longevity in this business. It's been around for 3 to 4 years now. And actually, talking with the maintainer, Travis Nielsen, they actually, came up with an operator that is, they decided what is the best way to do this, and they actually built an operator about 3 or 4 years ago. So in terms of Rook, it is a storage operator for Kubernetes. Number one, that's what it is. Okay, it's not storage, it's the control plane for storage. Number two, anywhere Kubernetes runs, it can run. And some of the main things that it can automate is that it can automate the deployment, configuration, upgrading, expanding of storage. And there's other things it can do too. But these things are become really critical when you're trying to, again, live within the Kubernetes framework and have the Kubernetes services and capabilities actually do these things for you. So this is what Rook has become very good at. And it works with the CSI. So if you've dealt with CSI as we have, if you look at something like the operator and you go to create a volume or delete a volume, it's not actually, in the case of this operator, that's doing that work. It's actually the CSI provisioner. So CSI, it works in concert with CSI. It's actually not in the control plane of actually creating and deleting volumes. So moving on, Apache 2.0 license, cloud native, the CNCF, it's been an incubating project for over a year now. Uses, like I said, all of the Kubernetes operators and custom types, and it's a framework for other storage providers other than, we'll see here. So these are some of the storage that Rook orchestrates in the way that I said. Now, not all of these are as fleshed out as Ceph. Ceph probably has the most community around it and the most sort of time and probably the most solid. But these other ones are there too. So if people want to put time and effort into these other ones, they can have more capability. For Ceph, we know it can deploy, it can orchestrate, and it can do the day 2 activities. And if there's going to be, just because there's going to be multiple talks at KubeCon, so if you look Rook, there'll be some talks on some of these other storage providers, and we're not going to speak about those today. So in terms of orchestration, as I already said, CSI is really sort of like what you call a sidecar. It's not, Rook orchestrates the deployment of CSI, but once CSI is up and running, it's actually doing it outside of Rook. The data layer there, we have for Ceph, we have file types of block, file, and object. And object, I think, is becoming quite interesting with the ability to do like an object storage class and be able to do object claims. So if we look at if you were to deploy Rook, and in particular the Rook-Ceph, you would see that it's a bunch of YAML definitions, and probably one of the most important ones is the cluster CRD. In the cluster CRD, you're going to give things like the versions of the storage software. You're going to tell it where the storage is. You're going to tell it different settings. So this would be true in any of the storage that Rook can orchestrate. But what makes, I think, this really nice from a paradigm is that some of people think Ceph is a bit complicated, I being one of them. And part of the reason it's so complicated is there's 1,000 knobs to turn, right? So by doing this sort of operator-based deployment, you're essentially turning the knobs, and you're making that decision ahead of time for the user. Now, you may make bad decisions, but it really takes sort of the complexity out of deploying these storage kinds of solutions. So I think the operator paradigm for storage is a really good thing, because what people don't want is except for people who learn the 1,000 options, most people don't want 1,000 options. So that's one thing by doing that. So once you turn your knobs a particular way, the operator watches for that, and not in all cases, but in some cases, if you go turn the knob another way, it turns it back, just like any operator. So you're sort of not guaranteed of not messing up, but you have a better chance because the operator is going to, as operators do, they say, what's my desired state? Okay, we're going to go back to that. So, did I already go through this one? No? Okay. So like I said, the cluster CRD is very critical, and we're gonna be able to manage upgrades with that with a very simple change to the CRD. We also can do some amount of health and monitoring of the cluster. In the case of like the Rook-Ceph operator, if it sees an OSD has gone down, it can bring the OSD back up. And actually, let me make sure that you know what an OSD is. These are the components of not Rook, but of Ceph. And an OSD, of course, is very critical to the storage cluster. So, a mon goes down, which is sort of like the orchestrator of the storage. The operator can bring it back up. RGW is your object gateway, S3 compatible, and MDS is for file storage. So we talked about, and again, this is specific to Rook, but I think these 3 types of storage are important to any application environment. So you have block, which is a read-write only, or once. That would be critical to any kind of systems that can't have multi-writer, or in the face of multi-writer become corrupted. We also, in some cases, need shared, or we need multi-writer. So for a multi-writer, multi-client situation, we need read-write many. and with the Ceph environment that's supplied by Ceph-FS. And then, like I said, object is really coming along. And when I say that, what I mean is that the fact that you can create a storage class to claim a bucket, and that bucket can be claimed within a namespace, and then an application can take basically advantage of that bucket within a namespace. So some of this is contribution that Red Hat has done recently, but anyway, I think object, the ease of using object this way, I think is going to bring up more probably ways of using it that we haven't really thought of yet. So just to sort of spell out all the components, and this is in a CSI driver environment. So we have the CSI provisioners, we have the plugins for both Ceph-FS and Ceph-RBD. If you were to look at this like kube control Git pods, each one of these would essentially be a pod. Some of them have more than one container. Ceph CSI is its own upstream project within the Ceph umbrella, and there's been a lot of effort that went into getting that to be able to be used both for Ceph-FS and Ceph-RBD. And then, of course, the Rook project. So really, you know, it's three different upstream projects here that are coming together for a solution. And I have RGW on there too. So as an example just of how you would take advantage of this, like I said, when you create or delete volumes, and right now our CSI driver for the Rook project isn't doing all of the capabilities, though it does have snapshot, so with Kubernetes. So there are a lot of capabilities if you look at the CSI, like I want to write a CSI driver. But the most important ones are create and delete volumes. So definitely have that, have snapshot, and you know, looking to have more capability there. But the actual work is done by CSI. Rook really is, as an operator, is not in that control plane. And similarly for mounting the volume, that is done at the app layer. So app says, you know, I want to create a volume, goes to the storage class. The storage class has the CSI provisioner, creates the volume, hands it back, and then it's mounted to the workload. So what I wanted to show here is just sort of an example of doing a rolling upgrade. So you see on the top left there, I have, this is the CRD. And all I did was I said, take this version, which is a mimic version, and go to that version of containerized Ceph. And you see there that the pods and the containers start restarting. As soon as, so first the mons restart, then the OSDs, then the Rados gateways, and then the file system pods. And at the end, I'm at Nautilus. Sagy is going to show you an example of this. The question we wanted to pose is, what happens to applications? Can I do this without downtime? So that's a rolling upgrade. And then for expanding the storage, so I now have updated my storage. I want to add more storage. And essentially, it's the same thing. I don't show the CRD here, but I would modify the cluster CRD. I hit save, and I basically go from having 9 OSDs to 12 OSDs. So again, these things are day 2 kinds of maintenance activities, and what you want to do is you still may take a maintenance window to do them, but you know, we're going to show that you know, in the future you could look to possibly do some of this work while applications are online. So I think next is the demo. Hand over to Sagy.
All right. Hey, hi, I'm Sagy Volkov from Red Hat Storage. I'm mainly focusing on performance, and I'm going to try and do a live demo. The only problem is I don't know how to mirror for this to work in here, and also I didn't know that I'm going to need to hold the microphone. I need.
If you go to preferences, you can mirror your desktop. So you need to get out of there somehow.
It's showing only over there.
Yeah.
So should I disconnect it?
No. Just you need to go to preferences and mirror the display.
Okay.
So you have preferences?
Yeah, well, it's only going to show over there.
Oh, you can't see it from there.
Sorry, guys. Display.
Display.
You're ready. Just
Then you
here's
want
your
you
lab.
want to go to
Yeah. Oh, show mirroring option when available. Okay. So let's connect this. Okay. And I don't see the mouse. Yeah, there it is.
look at the gather windows.
Oh, really? No.
Yeah, we're just trying to mirror this display.
It's a mirror it.
Oh, there we go. Sorry about that.
Mirror display.
Okay. Sorry about that.
Okay. Can anyone? Is this working? Oh.
Can we turn the sound up?
Okay. I am talking. Can you guys hear me? Okay. All right, cool. So I'll say just this, the demo is basically in the mercy of my Pixel phone, AT&T 5GE, and the gods of AWS. So hopefully everything is going to work just fine. And what we have in here is basically a 4 nodes cluster running on AWS. You got three worker nodes, one master. I guess the cheapest as possible. And these worker nodes are the ones that are going to run our application. They're also running Rook and Ceph. As Annette mentioned before, there's all kinds of Rook and Ceph components installed. For this demo, to make things more simple, only the RBD components or the block components of Ceph are installed. And so we're seeing our Ceph monitors in here. I don't know what that is. And we're seeing the Rook-Ceph Operator. And we have 3 pods of OSD that are basically consuming storage and providing storage for the application. So what I have already set up is a Postgres pod running, and I'm just going to go here and start a job that will run the sysbench for about 30 minutes, which is probably way more than what we need. And AT&T to work, yes. And it's creating this little work. So we're just going to monitor on the top right side the transaction per second. Again, this is very small database, very small storage. It's not the target here is just to show how you do these things while everything is running. And so Annette mentioned the CRD, and I'm going to go and edit this CRD. that basically control how you deploy Ceph and how you deploy Ceph via the Rook operator. And if we go down a little bit, it's long, and I can explain in details if someone wants after that, everything in here. But we have basically a path where it's called storage class device sets. We basically have, remember, 3 instances of AWS. We are marking them. We're assigning or requesting storage to be assigned to them for Ceph to be used via a label that I created that's called Ceph node name. And the first node is just called labeled as node 1. Second one is node 2, and so on. And the dynamically provisioned storage that we're using for these is basically for Ceph to use and then provide back is GP2 from AWS, of course. And as you can see in the top of each of these storage class device sets, there's a count for 1, because right now all we have, and I think I got some watch for this in here. All we have right now is 3 GP2 volume that we assign to our mons, which is a monitoring component or sort of for Ceph, and 3 GP2 volumes that are being used for Ceph to provide storage. So I'm going to go back to the CRD and basically just change each of these counts into 2. And before saving this, I'm going to start a tail of the Rook operator and some sound effects. All right. And so I'm just going to save this. 2 minutes remaining. I'm just going to save this. And yeah, that's a good sound effect for the 2 minutes remaining, by the way. I'm going to save the CRD. And what you see on the bottom left is that the Rook operator is immediately detecting a change of this CRD. And he's saying, OK, what do I need to do? Oh, I need to go and ask for some sort of a storage device from who, GP2, and all of these kind of things. And in a second, what we are going to see here is, we're going to do this here. We're going to see on the bottom right where we have the GP2 volume. As you can see, a few were added into that into the PVC requests. And on the top left, you can see new Ceph OSD pods coming up and being initialized. And I'm going to go to here, cancel this, and watch. If we go actually into Ceph, what we're seeing on the bottom right is that we have OSDs that are new, marked as down, because we haven't completely started the pods, the OSD pods, to actually run them, and they're not part of the cluster quorum. And once the Rook operator will start them, it's going to ask Ceph basically, or the storage provider, whether it's safe to start and use them. And then on the bottom right, as you can see, those OSDs are now up and running as OSDs and storage as that we can use. And all of this was done while our sysbench was running. At some point, you are going to see Ceph is saying, oh, I have a lot more storage. I want to spread my storage. It's probably fair to say that maybe you'll see a small dip, but that's the way with the software-defined storage. It's going to come back really fast. And that is the end of this demo of adding or expanding storage we're using Rook-Ceph. I don't have any more time. Okay, so
If you're interested, we do have another demo, which we didn't get to, of upgrading from Ceph Mimic to Mimic Nautilus, and we can show you that afterwards.
And that sounds like a phenomenal demo to have during the cocktail hour at 4.